Hello, good afternoon everyone. Today I am here to discuss our chapter name is motion. So let's start. So before starting, if I ask you one question, if I ask you tell me the distance of this place, or if I ask you tell me the distance of Jhansi railway station, or if I ask you tell me the distance of Delhi, so you will ask, sir, from where you want distance? We need a reference point or frame of reference. If I ask you that tell me the distance of Jhansi railway station to Delhi railway station, then you can tell me this much is the distance. If I ask you the distance from this place to Jhansi railway station, you can tell me the distance. So we need a reference or a reference point. Without a reference, we can't tell the position, we can't tell the distance, we can't tell the position of object. So to define anything, any position, we need a frame of reference. Frame of reference. So what is the meaning of this frame of reference? So let's understand the frame of reference. If I am here, if I ask you, tell me the position of this pen. Position means this pen is at rest or is in motion. So can you tell me? So you will say, sir, this pen is at rest. If I ask you, let's suppose I am in a moving train. I am sitting in a moving train, and if I ask my fellow passenger, tell me the position of this pen. So he will say, this position is the pen is at rest. Or if I ask someone who is outside the train, so what he will say? Yes, he will say this pen is in motion. Yeah. So we need to if I need to define the position of an object, whether it is at rest or it is in motion, we need a reference point. Reference point means from where you are taking observations. If you are taking observation from outside the pen, then similar pen having the different position, it is in motion. Or if I ask someone, if I am in a moving train, if I ask my fellow passenger, he will say the pen is at rest. So this pen at one time having two positions. So I can say it is absolute. This pen doesn't have an absolute position. It is neither absolute at rest nor in motion. So I need to define a reference point. Reference point means a place from where we take observations. You say, sir, don't understand what is the meaning of this. So let's suppose if this pen is here and you are standing from the door is behind the camera. So if someone is standing at the door and watching the position of this pen, so that door will call the frame of reference. If you are standing at a car or at a truck, so the truck will call the frame of reference. Or someone is watching this, observing its position from another terrace, another building. So that building or that terrace will call the frame of reference. So simple definition is, what is the frame of reference? The frame of reference means a place from where we take the observation. Second point is, who is the observer? If I need to define observer, can you tell me who is the observer or how to define the observer? Observer means a person who is taking observations. Observer word comes from the observation. Observer means a person who is taking the observations. Person who is taking observations. Objects. So let me give you one more example to understand this. Let's suppose this is a bus. Yeah, it is not looking like bus, but let's understand this is a bus. Okay. Having four wheels, we don't care about the wheel. One person is there. Okay, one person is there. Let's suppose his name is Raju. Okay, Raju. One person is here. standing in a bus, another person also is standing Okay, another person, one person, he missed his bus. These two persons left. This girl having the name, okay, this name is Tina and Raju, and one person also called Raj. Now, if I ask you, tell me the position of Tina. Tell me the position of Tina with respect to Raju. Okay, if Raju is observing Tina, so what is the position of Tina? So Tina is in motion. With respect to whom? With respect to Raju. If I ask you another question, tell me the position of Tina, same person Tina, with respect to Raj. Tell me the position of Tina with respect to Raj. So Tina is at rest. You can observe Tina is inside the bus, Raj is inside the bus. So if Raj is observing the Tina's position, so Tina will be at rest. Yes or no? So Tina is at rest with respect to Raj. With respect to Raju, she is in motion. With respect to Raj, she is at rest. So can I conclude one word that rest and motion is not an absolute word, or I can say rest and motion are relative words. Yeah, relative words. If I ask you, I am standing here and tell me the position, whether I am moving or I am at rest. So if someone is standing here or there, he will say, sir, you are at rest. If someone is observing my position from the moon, let's suppose someone is observing my position from the moon, so what he will say? He will say, I am in motion, because the earth is in motion. Earth is revolving around the sun. Sun, what is the sun? Sun is revolving around the galaxies, and galaxies also expanding. So everything in the universe is in motion. So rest and emotions are not absolute words, they are relative words. Or second definition, if I have to define what is the motion, can I call someone changing its position with respect to time? Yeah, something is changing its position with respect to time. If I say an object is changing its position with time. So you tell me whether this definition is complete or not. This is not completed. As I have given you example, I am standing inside a moving train. I have this train like this. Now this pen is changing its position with me. I am also changing its position with respect to time, but with respect to me, this pen is at rest. So I need to add one more word. If I have to define motion, motion means an object is changing its position with time with respect to reference point. Okay, reference point we have defined before. Frame of reference or reference point means a place from where we take observations. Observation or observer. This is the observer. Observer means a person who is taking observation called observer. Raju, Tina, here as we defined that Tina having two positions with respect to Raj, she is at rest. With respect to Raju, as Raju has missed the bus, Tina and Raj is traveling inside the bus, so it is in motion if the bus is moving forward. Okay, so let me give you another example, or I can call the rest emotions a relative word. So this kind of question was asked in the examination. If I give you one statement, absolute work. Statement 1, statement 2 is rest and motion are relative. This should be the answer. Can you tell me the answer? Rest and motion are absolute work. There is nothing absolute in this world which you can say it is at rest or it is in motion. These are the relative terms. So second options are correct. Now, before going inside, going further in the motion chapter, so in motion chapter we have to define few physical quantities. Physical quantities means we have some physical quantities like distance. Can you tell me the distance? Distance means if I had position A and I need to go at the position B. If I go from this way, I take this path and reaches from here. Can I call this? This is a distance. Distance 1. If someone is taking this way and reaches from this, I can call this distance 2. So distance means actual path covered by an object. What is how to define distance? The actual path covered by an object. It is a scalar quantity or vector quantity. So distance we need to define distance. We need to define the direction with distance. So distance is a scalar quantity. It is a scalar quantity. What is the SI unit? Distance is measured in meter. Or can you tell me one more thing? Distance is path dependent or not? Let's understand this. This is an object having a position A, B. If someone is going from this way to this way. These two having the same distance or different distance. So this path looks little greater path, little big path. So distance D1, D2. Let's suppose this is 10 kilometer. This is 9 kilometer. So distance depends on path. So I can write distance depends on path. Can you tell me the distance can be negative? If person is moving from here, coming back to the same point. So what is the distance? So distance I have to measure all these paths up to here. So distance can't be negative. It cannot be negative. It can be zero. Can you tell me distance can be zero? Yes. If a object having the position here and is standing here only, time is passing, it is standing here. So what is his distance? So its distance is zero. So it can be positive or zero. Now, okay, based on this, if I give you some neat examples, if I give you some figures, this is distance versus time graph is given. Okay, so now we will see in the first graph. Distance versus time is given. Distance versus time is given. Distance versus time is given. Now we tell me. This is complete. Now tell me whether this graph is possible or not. So to define whether this graph is possible, this distance time graph is possible, any distance time graph is possible or not, you have to check whether the distance is positive or zero, or is it negative. So can you tell me, if time is increasing, if the graph is given, let's suppose this is at 1 second, this is at 2 seconds, 4 seconds, 5 seconds. The distance is say 1 kilometer, 3 kilometer, 4 kilometer. Let's suppose it is increasing so at 1 second distance is 1, at 2 seconds distance is this. So as time is increasing, distance is also increasing positive. So this is positive graph. So it is possible. Yes, possible. Tell me whether this graph is possible or not. Distance time graph, it is possible or not. You can say that it is starting at the highest position. Let's suppose it is a 10 kilometer. This is 9, this is 8, 6, 4, 3, 2, 1. Okay. And the time is for this, let's suppose this is 1 second, this is 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6, 7. So as time is increasing, its first distance is 10 at 1 second, at 2 seconds it is 9, at 3 seconds it is 8. It is decreasing, means the graph is negative. So as we know, distance cannot be negative. So this graph is not possible. Can you tell me this graph is possible or not? That's all. So in this graph, time is passing, distance is 0, 0, 0, 0, 0. At this time, this is any time t equal to, let's say, t1 second or 5 second or 10 second, any numeric value you can consider. T equal, let's suppose 10 second. After t equal to 10 second, it is going positive. It is increasing, linearly increasing graph. So this graph is possible. How this is possible? Let's suppose I am standing here. Time is increasing. I am not moving. I am standing here. Time is increasing, increasing, increasing. After t equal to t1 second, let's suppose t equal to 10 second, t equal to 20 seconds, any time. Now I start moving. So my distance is increasing. Previously I was at rest, then object start moving. So this graph is possible. Tell me whether this graph is possible or not. Here 0, but before time means before 0 time there is some negative values of distance. Distance cannot be negative. This is a y-axis, distance is given. This is negative y. Negative y is negative distance. So not possible. Not possible. You understand this? I hope you understand this. Let me tell you another example. Or another physical quantity. We will discuss another physical quantity. Another physical quantity is, let me tell you another physical quantity. If a person having position at A and it is moving to B, it is going this way, this way, this way, reaches to this. Another person reaches another path 2 is taking here to here. Okay. This is path 1. This is path 2. Can I go in this way also? If I connect this one to this one by a straight line, okay, can you see a straight line from there to there? So what we can call, this is called linear. This is straight line, linear line. This is called linear motion. Or I have to define this in one word, so I call it displacement. Do you know what is the displacement? So displacement is the shortest path. What is the distance? Distance is actual path. Actual path covered by an object. Distance means actual path covered by an object. Displacement, shortest path covered by the object. Second point, it is a vector quantity or scalar quantity. From A to B, we have to define the direction, which is a vector quantity. It is a scalar quantity. What is the SI unit? Same, both are the same. Distance and displacement both are the same. Only difference is displacement is a vector quantity. It is a scalar quantity. It is an actual path, whatever the path is covering. So it is called actual path covered by an object. It is called the shortest path covered by an object. So it is SI unit is meter. Its SI unit is also meter. Another thing, can you tell me? Distance, as we studied, that distance cannot be negative. Displacement can be negative. Displacement, it can be negative 0 and positive. How? If this object is started from here and moving here and reaches to the same point. So what is the distance? What is the shortest path? Same shortest path. So it is a zero displacement. If an object is moving this way and reaches to here, so it is a negative displacement. If an object is moving from here and reaches to this point, so if you connect the initial and final point, this is called initial, this is called final. If you connect by a straight line, so this is called positive displacement. So if I ask you whether this graph is defined or not in terms of displacement, if displacement time graph is given, so can you tell me this graph is possible or not? This graph is possible. So displacement can be negative, positive or 0. So yes, possible. This is as simple as that. One more example if I give you, that initial position of an object is at A and finally he reaches to B. Okay, which coordinated 1, 2 and 3, which coordinated 5, 7 and 8. So can you tell me the displacement? The shortest path. This is the shortest path. This is displacement. So displacement means 1, 2, 3. Coordinate means what? 1, 2, 3. That means it is given I, J, K. You remember the vectors? I, J, K. So displacement means change in position vector. Displacement means change in position vector. What is the position vector of here? If I need to write the vector in vector form, so it's I, J, K. 1I plus 2J plus 3K. Can you write this? I plus 2J plus 3K. Can you write this? 5I plus 7J plus 8K. Now I want change in position vector. So what is the meaning of this change in position vector? Change in position vector means if the position vector is R and I need delta R. Delta R means this position minus this position. So the vector form of this position is 5I plus 7J plus 8K minus change means final minus initial. Change means what? Final position minus initial position. It's a change. So I plus 2J plus 3K. 5I minus I. What is the answer? 4I plus 7J minus 2J. It is a 5J. 8J minus 3K. It is a 5K. This is the displacement in the vector form. If I want change in position in the absolute terms, if I want modulus of this, so it is the under root of 4 square plus 5 square plus 5 square. 4 square is 16, 5 square is 25 plus 5 square is 25. You can add 25 plus 25 is 50 plus 16 is 66. This is the arms. This is the displacement of from this point to that point.